Good day, everyone, and welcome to another problem-solving session with Special Maths Academy. So we'll be having a redo of problem 40 because I made a mistake in the earlier upload. It says all but one are not possible residue of P modulo 42. And actually, looking back at this question, we see that there's only one possible residue of P modulo 42. And actually, let's try and get that. So we're looking for what P is congruent to mod 42. And to do this, is best we consider the prime factorization of 42. So we see that 42 is equal to 2 times 3 times 7, okay? And then we consider for each case. So let's find what P is congruent to mod 2. Okay, since P and Q are prime numbers, it means if P is congruent to 0 mod 2, then that will imply that P is equal to 2 because P is a prime number. Okay, so that's one of the nice things about working with prime numbers. So if P is equal to 42, we'll have 2 raised to the power 2 times 2 plus 2 equals to 21 q squared. So we have 2 raised to the power 4, which is 16 plus 2, which is 18, equals to 21 q squared. Okay, and this is a contradiction. Why? Because we have 18, which is equal to 21 q squared, is greater than or equal to 21, and so this is a contradiction. Okay, so it means that P is congruent to 1 mod 2. So let's keep that somewhere. Okay, now we'll look for what P is congruent to mod 3. And so to do that, we just take mod 3 on both sides of this equation. So I'll just erase this. Okay, and to understand why I'm taking the case for each of the prime factors of 42, you can read about Chinese remainder theorem, and I'm going to drop a link in the description where you can read a bit about it. Okay, so let's continue. So we take mod 3 on both sides. We see that 3 divides 21 q squared. 3 divides 21. So we have 2 raised to the power 2p plus P is congruent to 0 mod 3. And so we have 2 raised to the power 2, which is 4. It's congruent to 0 mod 3. So I have 4 raised to the power P plus P congruent to 0 mod 3. And so we have that 4 is congruent to 1 mod 3. So this can be put to 1 raised to the power P. Write this P well. 1 raised to the power P plus P is congruent to 0 mod 3. So I have P plus 1 congruent to 3 mod 3. So P is congruent to 2 mod 3. Okay, so I have P is congruent to 2 mod 3. Okay, so since P is congruent to 1 mod 2, we can say let P be equal to some 2k minus 1 for some positive integer k. Okay, and now we have that 2k minus 1 is congruent to that P is congruent to 2 mod 3. Okay, so this implies that 2k is congruent to 1. Sorry, this is 3 congruent to 1 plus 2, 3 mod 3, and so we have 2k is congruent to 0 mod 3, and so we have k is congruent to 0 mod 3. So we can say set k to be equal to 3t for some integer t. So we have P equals to 2 into 3t minus 1, which is equal to 6t minus 1 for some integer t. Okay, So we have that. So I basically want to find out what P is congruent to mode 6. Why? Because I'm going to apply Fermat's little theorem. And so I'll also drop a link for Fermat's little theorem for those of us that are not conversant with it. Okay. So P, which is equal to 60 minus 1. So it means that P is congruent to 60 minus 1 mode 6. So we have P is congruent to minus 1 mode 6. So we have P is congruent to, we'll add 6 to minus 1. So we have P is congruent to 5 mode 6. Okay. So we have 2P. Why am I finding 2P? Because we have a power of 2P here. Is congruent to 10, which is congruent to 4 mode 6. Okay, so let's quickly go into this. So basically, I'm going to apply Fermat's little theorem here. Okay, so I'll just put this. So let 2P, since 2P is congruent to 4 mode 6, so we can say let 2P be equals to some 6m plus 4. Okay, and then we put that in the power. So we have 2 raised to power 6m plus 4 plus P congruent to 21q squared mode 7. And we know that 7 divides 21. So this is the same thing as 2 raised to power 6 raised to power m times 2 raised to power 4 plus P congruent to 0 mode 7. And so 2 raised to power 6 is 64. Okay. Raised to power m times 2 raised to power 4 plus P congruent to 0 mode 7. And so we see that 64 is congruent to 1 mode 7, so we can just put 1 here. And since 1 raised to power m is 1, so we can actually just leave it at 2 raised to power 4 plus P congruent to 0 mode 7. And so 2 raised to power 4 is 16 plus P congruent to 0 mode 7. And so we see that this is 16 is congruent to 2 mode 7, so we have P is congruent to minus 2, which is congruent to 5 when you add 7 to minus 2 mode 7. Okay, so we have P is congruent to 5 mode 7. Okay, so we have P congruent to 5 mode 7 and P congruent to 5 mode 6. So it means that P minus 5. 7 divides P minus 5 and 6 divides P minus 5. And since 7 and 6 are relatively prime, it implies that 42 divides P minus 5. And so P is congruent to 5 mode 42. Okay, so the answer is option A, so 5 mode 42. Okay, so this is just one of those cases where you have to actually pay attention to the problem and also try to understand the problem, because actually there's only one possible residue modulo 42, and that is 5. Okay, that'll be all for this video. See you guys in the next video, and don't forget to share, like, subscribe, comment, and keep solving maths. Bye.